Hey guys, I thought it would be good for you all if I went through and just videoed a couple examples of graphing these trig functions so that you had them as a reference to look back at in case you're still confusing amplitude, frequency, period, and all that. So I'm looking at the example from, I think it was day 3 notes. I'm on page 9 here, where I'm looking at y equals 3 sine of 2x plus pi over 3. Now I need to answer some questions about it first before I go through and graph it. So the first thing I got to do here is recognize that the frequency, this 2, needs to be factored out. So I'm going to rewrite this as y equals 3 sine of 2 times x plus pi over 6. So pi over 3 divided by 2 gives me pi over 6. That's how I got that. So the amplitude of this graph comes from this leading number, which is 3. The frequency is this number here, 2. So that means between 0 and 2 pi, you would see 2 full sine curves. But if I only want to see one sine curve, that's where the period comes from. The period is always equal to 2 pi divided by the frequency. So in this case, 2 pi divided by 2 is just pi. So over pi units, I will see one cycle of sine. Now the phase shift, which is its horizontal shift, is determined by this number right here. Now it's going to be the opposite sign, so negative pi over 6, which means it's moving to the left. And it may be helpful for you to convert back to degrees from time to time. So if you think of negative pi over 6, that's the same thing as left 30 degrees, which when we set up our boxes down here is going to be one box. Okay, so let's set up our axes here. So since I'm only shifting by pi over 6, I'm going to keep the same scale that I normally do. So every 3 boxes is pi over 2. Which makes every box pi over 6. Okay, and make sure I go high enough so that my amplitude is 3 on the y-axis. Now, what I'm going to do first is graph y equals 3 sine of 2x. So notice that I don't have the shift or anything. I'm going to graph this, and then I'm going to move everything over pi over 6 units. So I'll do this in a lighter color, I guess, so that we're keeping track here. I'll do it in, I don't know, I'll do it in this like pink color. So sine on this curve is going to be pi over pi units because that's the period. So sine is going to start on the midline at 0, 0 and end, so one cycle is going to end at pi 0. So that means halfway in between these points, sine's going to hit the x-axis again. Now, keep in mind how a sine curve normally looks. I'll just kind of sketch it off to the side over here. Looks like that. And there's been no reflection in the x-axis, so it's going to go in between these 2 points halfway up to 3, because that's my amplitude. Oops. And then halfway between pi over 2 and pi, it's going to go down to negative 3. So if I lightly sketch in, I'll just dash this. This is the function before it's been shifted to the left 30 degrees. Now keep in mind, again, that each of these boxes is worth 30 degrees, or pi over 6. So I'm going to take each of these points then, of my pink function, and move them to the left. One box. Oops. So I'll do this in a solid navy blue. Oops, I don't like that curve. Okay, and then to finish it off, I'm going to label my final product. So this is y is equal to 3 sine of 2x plus pi over 3. And there you have it. So again, the navy blue curve is where I ended up here. The pink curve I used to help me see what it's going to look like before I shift it to the left. So let's try another one. Okay, so now I've turned to page 11 here. There's the number. And I'm looking at this function, which has a lot going on to it. I've got a reflection in the x-axis, an amplitude of 2, a frequency of 2, a phase shift of negative pi over 4, and then it shifted down 3. So I threw a lot at you. And I'm going to graph one cycle of this. So let's first answer some questions about it. The amplitude is 2, and the frequency is 2, which means the period, which is 2 pi divided by 2, is pi. So if I want to see one cycle of this, it'll be over pi units. The phase shift is negative pi over 4, which means it's moving to the left pi over 4 units, which is 45 degrees, if that helps. So since I'm shifting by negative 45 degrees, or to the left 45 degrees, the way I normally set up my axes, where every box is worth 30 degrees, is not really conducive to shifting things around by 45 degrees. So here is an instance where I'm going to change the interval on the x-axis. So let's see, can I get down here? Okay, so instead what I'm going to do is make every 2 boxes pi over 4 units. So that's 45 degrees. So then if I keep going, this is 2 pi over 4, or pi over 2. This is 3 pi over 4. And then lastly, this is 4 pi over 4, or pi units. So when I'm graphing the period of this graph, here's the pi units that I'm looking at. Okay, now the amplitude here is going to be 2, so make sure I have enough room to go to an amplitude of 2 on the y-axis. I have to keep shifting because otherwise I don't want it to get too small. I'm trying to look up here and see what I have to do. So I'm going to graph this curve without any shifts first. So that means, if you need to write it off to the side, I'm going to first graph y equals negative 2 cosine of 2x. So notice I've eliminated the phase shift and the vertical shift. Okay, so what this is going to look like, I'll do a different color here. Between 0 and pi units, I'm going to have one of these cosine curves. So maybe I'll just temporarily put a line here so you know this is where I'm going to stop. Now, since there's been a reflection in the x-axis, I'm not going to start at positive 2. I'm going to start at negative 2 with that amplitude. Which means over here, where I kind of sketched in a line so I knew where to stop, at pi, I'm going to end at negative 2. Okay, I'm going to get rid of this for a second. Okay, so then, because of how cosine looks, halfway between these points, so this is how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so halfway between is at pi over 2. I'm going to be at a max of 2, which means then halfway between here, so this is a distance of 4 boxes, so right here and right here, it's going to cross the x-axis. And, oops, I don't like how that looks. Oopsies. I'm going to sketch in this curve. So again, that pink function is the function without the left or right or down, whatever, without the phase shift or the vertical shift. So now I'm going to take this pink function and I'm going to shift everything to the left 45 degrees and then down 3. Did I forget to mention that somewhere? Oh, here it is. It has to go down 3. Whoops, forgot to fill in the vertical shift. Okay, so I'm going to label in the negative direction because I'm going to have to move everything to the left pi over 4 units. So this is a negative pi over 4. I'll do it in green. Mix it up a bit. So again, I'm moving everything to the left, pi over 4 units, and then I'm going down another 3. That's what it was, right? 3? Yes, 3. Okay, so this is what you're going to see me doing for the next few seconds. Okay, so what you see in green is the final answer. Sorry, my screen's getting all over the place. So I've got y equals negative 2 cosine of x minus pi over 4 minus 3. And just do yourself a nice little visual check. Does this look like it has an amplitude of 2? And you can compare that with your new midline right there at y equals negative 3. So from this midline, it looks like it's went up 2 units and it went down 2 units, so that's good. It looks like it's been reflected from where it was. So I did the reflection already in the first part. And I moved everything to the left pi over 4 and down 3, which makes sense why it looks like it's nice and centered around my new midline. So just be aware of what the midline is, because I could ask you a question like, what's the midline now of this function? Okay, if we're talking about domain and range here, the domain of any cosine or sine curve is all reals. And the range looks like it's between negative 5 and negative 1. So thanks for watching my video. I hope this helped you guys study for your quiz on Friday. So if you've watched this video, what I want you to do is write this on the back of your quiz. Banana, okay? Thanks.